answer. Any questions? So first, the parent functions that you guys had for the graphs. So is everybody okay with general shape for square root and cube root? Okay, so we should kind of remember these. Try not to mix up your cube root with your cubic. Remember, like a cube root is very flat. It takes so long for it to grow. Like before this function can reach up to 10, do you guys know how far over it has to go? It's a cube root function. So how far over would it have to go on the x-axis before my y-coordinate is 10? What number would you have to take the cube root of to get 10? 1,000. So you're not even going to reach up to 10 until you go all the way over to 1,000. So cube root grows really slowly, okay? Whereas a cubic shoots really up really fast because it's cubing things. So try to remember that because sometimes you guys mix up the parent functions and it's really hard to give you any credit for what you've graphed because it's not graphing the right type of function, okay? And then remember that when we build our parent functions, we usually start with 0, 0, and we pick numbers around them, like 1 and 2 and -1 and -2. And notice these ones are a little bit different, okay? And they're different by what's easy to calculate or what's allowed. So in a square root, we didn't use any of the negatives because we can't take a square root of a negative in the real number system. So instead, we're just doing positive, but we didn't go 0, 1, 2, 3 because 2 and 3 are not nice numbers to take the square root of. So we did 0, 1, and we purposely skipped 2 and 3. We're picking the easiest numbers for us to take the square root of that are closest to 0, okay? And then cube root, you can do negatives, okay, like we talked about previously. However, I wouldn't want to pick -1 and -2 because I don't know the cube root of -2. So that's why you see -8 and 8 here instead of 2 and -2, strictly out of convenience, okay, because those are things I can plot easily on my graph. They're kind of far away, but not that far away. So I'm choosing numbers I know that I can take the cube root of instead of sticking with the 2 and -2. Okay. All right. Are we okay with the parent functions and how we built them? Any questions about them? So you guys are okay with these tables. You know where they're coming from because you're going to need them to build your transformed functions. And then are you okay with the characteristics? So as we go through this in class, we're reviewing all the characteristics from Algebra 2. But really our focus, like I asked you on the last quiz, I'm going to ask you things about the HK, domain, range, finding intercepts, and then listing out the transformations in words, and we'll write those in a minute for the transformed functions. So are there any questions? Notice that for your square root function, since it has a distinctive endpoint, we have domain and range that are different, okay? They're not just -infinity to infinity kind of idea, okay? So any questions about any of the information that goes along with the graphs, the characteristics? So you guys feel comfortable with square root and cube root parent functions? Yeah, Clay. Uh-huh. It doesn't matter. So, yeah, so like I've gone and talked to the calc teacher and all of this. So like even the students that take like an AP calc exam, remember the bracket means like you're including the number and the parenthesis means you're not. So for increasing and decreasing intervals, it's weird at an endpoint or a turning point because like are they part of the interval or not? And mathematicians can't really come to consensus on that. There's not like one answer, and it's not important enough for them to come to consensus on it, so they don't care how you write it, just that it's the boundary for the increasing or decreasing. Okay? All right. Any other questions about the characteristics? Okay, so let's look at the transformed graphs and how we got them. So we'll look at the square root function first, okay? And notice that I took it and I rewrote it, okay? If I'm going to graph it by transformations, I need to rewrite it in this format instead of seeing it like this. These are the same thing. Like if I distribute back that -1/2, I'm going to get exactly what's there. Why did I find it so important that I rewrite it this way instead of just looking at it like it was originally given to me? There's a reason. Yeah, Jacob. Good. If you guys look at the original equation, my guess is you're going to look at that and you're going to think h is -2 and k is -3. But that's not correct because we've only studied h when it's part of a group called x minus h, not like 1/2 x minus h. So that half is messing things up. So we need to look at it separated from that quantity before we can see the true H value. So only when I write it like this do I see that the HK of this function should be positive 4 or negative 3. Okay, so is everybody okay with why the HK values would be positive 4 or negative 3 and how I rewrote the equation? And if not, ask some questions. Yeah, right. So remember when you guys factor stuff out, so we tend to be pretty good at it when the numbers are simpler. So if I have like 5x plus 10, you guys are pretty good usually. If I say, oh, if I take out the 5, this is what I get. So remember to take out 5 because it's that number. And the way I'm getting 2 is because 10 divided by 5. So what I had before was this. When I take out that negative 1/2, if I want to know what's here, and it's a little more difficult for me to understand the concept, I want to do the same thing. I had 10, I divided it by 5, it left me with 2. So in this case, I had 2. I would be dividing it by negative 1/2 to see what I'm left with. And so if I literally just go off to the side and do like 2 divided by negative 1/2, that means 2 times negative where I'm getting 4 from. Is that okay? So are we okay with the idea? This is what makes what we're doing right now a little bit different from what you guys did in Algebra 2. You guys didn't have any of these horizontal stretching and compression. So you didn't have ever any value right here. You had A's, H's, and K's, and that was it. Okay, and it simplified the process a little bit. But now we're looking at this value here. So this is the one thing that makes it different and something we really have to be aware of. Okay? So is everybody okay with how we rewrote that and that our HK is the 4, negative 3? All right, so then here's how I made the charts. So first thing I want to comment on is the vertical stuff. So the vertical stuff is the stuff that's not happening inside the square root. The stuff that's happening inside the square root is happening to x. That is all horizontal changing. The stuff beyond the square root is the vertical stuff, so the only thing we have is the -3. So what transformation should we write down next to this graph? And you guys are going to write it down right now, okay? What would you write down in words? Because this is the place that you struggled a little bit on your quizzes. What do we write down for that -3 as the official way that the graph is transformed by that? Clear? Okay, good. So it's a vertical shift down 3. So you guys can say shift down 3, translation down 3, okay? I won't mark off if you say shift down 3 and not vertical because you say down 3, so I know that it's vertical. So that will be okay. So everything else that's happening to our graph is horizontal. The thing that's most similar to what happened with the 3 is what's happening with the 4. What transformation is the 4 causing from that function? So someone besides Claire, she just gave us the last one. What's happening with the 4? How would we describe this transformation? So here we said it was a shift or a translation. Down 3, what's happening right here with the 4? Yeah, that's good. Shifted to the right 4. Okay? So we have a shift down 3 and to the right 4. The rest of the transformations are right here. And this is actually 2 different things that are happening. The negative is causing one type of transformation, and the 2 is causing another. And first of all, I did not make an error here in writing 2. Do you guys remember what we discussed before? That the half there is kind of slowing down the x's. They're not getting to those y heights as fast as they used to. They're kind of like taking half the speed to get there, so it's taking them forever to get to the y value that they used to get to. But on a graph, we want to measure the distance, and so the distance always has that reciprocal relationship with the number that's in the problem. The b value here was 1/2, but when I go to perform the transformation, I'm actually using the reciprocal of 1/2, which is 2. Okay, so I didn't make a mistake there. That's because the horizontal stretching and compressing works. The number in the equation means something, but it does not mean the distance. And so to get it to mean the distance, we have to use the reciprocal, okay? So I used 2 here. So the 2 is causing one transformation, but the negative is causing another. Every time you see something being multiplied by a negative, what kind of transformation do you know you have to list? Multiplying by a negative, so changing the signs of things causes what transformation? Good, a reflection, okay? And then after the word reflection, you need to list over which axis it's happening. Okay, so for this graph, we want to list a reflection over, and if you're unsure, look at what's happening. Here the negative is affecting x, meaning these x's that were positive are becoming negative, and these x's that were negative are becoming positive. When I'm doing this, which axis am I flipping over? I'm changing the x, but I'm flipping over the y-axis if I'm going like this, right? So with the negative here, this would be a reflection over the y-axis. So every time you're multiplying by a negative, you should list a reflection. With the word reflection should come over which axis you're flipping, okay? And then don't look here, okay? Look at what you actually did for the transformation. Said 1/2. But when I translate it to measuring distance, I use it as multiplying and multiply them by 2, okay? Are you stretching or compressing? Okay? Does multiplying by 2 make things a bigger distance or a smaller distance? Bigger, okay? Multiplying by 2 makes numbers larger. So in this case, if you're multiplying by 2, you're stretching it, you're making the distance bigger, okay? And because it's happening to x, it's horizontal. So the last transformation you should have listed there is that you have a horizontal stretch. Okay? So again, you guys should have listed a reflection over the y-axis, a horizontal stretch, and shifting to the right 4 and down 3. Okay? Any questions on the transformations that I was just pointing out? So remember, our emphasis, you guys saw it on your quiz last week. You're graphing, you're telling me HK, domain, range, and transformations, and then you're listing a table for me. A table that are points that you actually graphed. Whether you get that how I did or a different way, if you finish your graph first and then make the table, it's fine. But the table should match the points on your graph. Okay? Transformations? No. So this question came up a couple times during second period also. So what Matt asked was, will there always be 4? So there could be none. The parent functions have no transformations, right? There could be 1. Like, look at this one. What if all I did was the +2? That would just be 1 transformation. So it could range from 0 all the way up to possibly 6 different transformations, because you could have a reflection in either way, so a reflection over the x or reflection over the y. You could have either a vertical stretch or compression and then a horizontal stretch or compression, and then you can have a shift right or left and a shift up or down. So the most you could have is 6, but the parents have none, and it can be anything in between there. It just depends on how many different numbers are changing your equation. Okay, so don't try to latch onto a pattern of how many transformations you're going to have, or when it's a cube root, we only list 2. Totally just depends on where they put the numbers. Okay. All right, are we good with our square root? So are we okay with what the graph looks like, how we got the points, and we now understand what we would write down for the transformations? All right, so look at the cube root. Okay. So this time, I did not rewrite the equation. Okay, somebody tell me why I was not concerned with rewriting the equation. This is really important. This is why I'm emphasizing this part of it. So why was I so concerned about writing it with a square root, but now I get to the cube root and I don't rewrite the equation? Seth? Good. So it's already in the form I wanted. Under here with x, it doesn't have any b value multiplying x. It just has x plus 2. So it already has the x minus h package without anything extra in there that was different than the way that we studied it. Okay, so it's good that way. So you can immediately see your h and your k as negative 2, 6. Okay? All right, somebody give me a transformation that we would write down for this problem. So if this was on your quiz and you were listing the transformations out in words, somebody raise your hand and give me one. Sean.
Shift left 2.
Okay, so Sean says a shift left 2. So that's coming from here, right? My h value of negative 2, and you're seeing that transformation right here in my chart. Brett. Good. Shift up 6. So that's coming from here, and you're seeing that transformation right here in my chart. Okay? All right, what else? Claire?
I know that it stretches, right?
Good. Okay, so what Claire said is she knows that it stretches because she sees us multiplying by 2, and she's correct. She said she doesn't know if it's horizontal or vertical. So can somebody tell us which one it is? So she's right. There's a stretch, but you do have to put a word in front of that. Is it horizontal or vertical? And then tell us how you knew. Clayton.
It's a vertical stretch. You have to multiply by 2.
Good. So it's a vertical stretch. And so if you're having that hard time figuring out why it's vertical or horizontal, remember, everything that's happening to y is a vertical type of change, and everything that's happening to x is horizontal. So if you know that it's happening to y, but you're having trouble with the horizontal vertical words, look back at that chart or think about where it's happening.
So does that mean that the a value will be vertical and the value will be horizontal?
Yep. So B and H are totally horizontal stuff, and A and K are totally vertical stuff. And all the horizontal stuff is like whack, right? It says 2 or it says a half in the equation, but we're supposed to multiply by 2. It says -4, but really we +4, whereas all the vertical changes are much more straightforward. And it just has to do with the fact that you do them after you already got the answer from the function instead of trying to shift it before that. Okay? Are we okay with the graphs of the functions and the transformations and where we got them from? So interactive. I'm doing the best I can. You guys know I chose teaching instead of doing other things with math because I get to talk about math to people and like help people with it and like interact with human beings. But some days, no, right? Okay. So then go ahead and take a look at the list of characteristics of the graph and make sure you're okay with what we have there. The things that we haven't gone through and we'll go through in a minute are the X and Y intercepts. They won't take too long, but we'll make sure that you guys can solve for those. But otherwise, everything else is something that we learned in Algebra 2 and should be able to get from the graph. Increasing, decreasing intervals, domain and range, if it's 1-to-1, stuff like that. Is there any questions about those characteristics? Like if you still don't understand what one of them are, you don't know why we wrote the domain or range a certain way. So then you guys are good with parent functions. You have comfort with square root and cube root parent functions. You feel like you know how to do the transformations of the graph. We do them in a similar fashion that we did quadratic and cubics, okay? And you feel like you can list out the transformations hopefully now a little bit better than we could before about our stretching, compressing, reflecting, and shifting, okay? And then let's just how to find the intercepts, and then we'll be done, and you guys can work on homework 4 and 5, and then I have something I was supposed to stamp yesterday, right, that I have to stamp today. It was a classwork. We worked in it in class on Monday, so don't freak out if anybody's scared. All right, we're going to start with the square root function, and I'm actually going to start with the y-intercept. So we talked with quadratics and cubics about the y-intercept being a little bit simpler, and I told you guys not to take that word as in like something is simple and shouldn't be difficult for you because I can't be the judge of that. Everything can be difficult. But simpler than the x-intercept in the fact that when you're finding y and plugging in for x, everything's already on one side. So you don't have to do a bunch of solving. You just have to finish the arithmetic in the order that you're supposed to do it. And then the one thing I want to point out here, so we plug in 0. We get 0 plus 2, which just gives us 2 underneath the radical. And then you guys are going to be doing this without a calculator, okay? So I don't expect you to know what rad2 is, but I expect you to grow kind of content with this idea of listing square root of 2 minus 3 is an exact way to write that function when you're not going to estimate it with a decimal. That's okay, that's how we would write it, and that's all right, okay? And then is everybody okay with, a question came up last period, are we okay with why that square root does not have a plus or minus in front of it? And it should not have a plus or minus, okay? When somebody's asking you to calculate a radical, the radical is positive, just like a number is positive if we don't write a sign in front of it, or it's negative if we write a negative sign in front of it. Remember, we only use plus or minus when we had something squared and we took square roots of both sides of something to figure it out, okay? So that's not this situation here, we're just plugging it. Okay? And then when you guys want to find the x-intercept, we're going to set y equal to 0. And I'm not using my equation in that form where we like rewrote it to see the x minus h. You can. But to me, when I'm solving, that's like extra work. That's like extra parentheses and stuff I'm going to have to deal with later. I needed that when I was graphing to see the h value, but solving doesn't have any specific setup. So I'm good with not having that. And then we would get the radical part alone, so we'd add 3 to both sides. And then what should we do from here? So how do you guys solve something like this, Josh? Good. So we're going to square both sides. Since squaring is the inverse of square rooting, so it will undo the radical and give us just this expression on this side, and on this side we'll have 9. Okay. And then we'll just finish solving it like you guys normally would. So I'm going to subtract 2. And then I'm going to multiply both sides by -2 to cancel the -1/2 that's in front of x. So I get x equals -14. So my x-intercept occurs at that point. Okay. So probably the hardest x-intercepts to find are with the quadratic because we take square roots of both sides and have to use the plus or minus. But with most of the other functions like this, if you can get the function part alone and then square it or do whatever you have to do to undo it, and then just finish solving for x, you'll be able to get the answer. With logs and exponents, it'll be a little more complicated. All right, and then we want to do the same thing for your cube roots. So same idea, just wherever you have your graphs and your cube root equation that you wrote down the stuff from yesterday, we're going to go ahead and put our intercepts for our cube root as well. And I'll put this back up if anybody needs it. All right, so same idea if we start with the y-intercept. And just plug in 0 for x. There's not a lot of calculating we can do here because under the cube root we have 0 plus 2, which is 2. And I don't know the cube root of 2. So again, I don't need you to be an expert on radicals. I just need you to be content with leaving that as the way that we would calculate this point. Okay. And then for the x-intercept, we're going to set y equal to 0. And same things as before. We really want to get this part that has x in it alone. So we want the cube root portion alone. So we need to cancel out the 6 and the 2. So we'll subtract 6 from both sides and divide by 2. And then in this case, what do I need to do from here in order to keep on solving? Cube it, right? So cube root and cubes are inverses, square roots and squares. So sides, -3 cubed is -27. And so then I would just subtract 2 to finish for x. So that would be my x-intercept. Okay? So you guys have a couple of things that you can be working on. I'm going to come around and stamp the third classwork. So the second one was on Desmos. You don't need to stamp for it. It's recorded separately. And then the first one we already stamped. So on Monday, I gave you guys some piecewise functions that include quadratics, and you guys worked on that during class. So I'm going to come around and stamp that. While I'm doing that, you guys should be working on homeworks 4 and 5. So there's a copy of it up here if you want to take a picture or something. Don't take a picture of homeworks 2 and 3. Make sure you're doing the right one. So just like 2 and 3 was quadratics and cubics, 4 and 5 is square roots and cube roots. So 8 of each graph, where you have to graph, make the chart, list the domain, the range, the HK, and make sure that you have a table that matches your graph. And so you guys should do that because tomorrow on your quiz there will be problems like that. So ending today with that practice would be a good idea and going home and doing some of them tonight. And I'll post solutions for everything tonight as well so you can check them if you need to, okay?